Hello. Now we will study some important points regarding the capacitance. So the capacitance we define as Q by V. C is Q by V. So the first point regarding this capacitance is it's a scalar quantity. It's a scalar quantity. Obviously, this capacitance we are getting from Q and V, which both are scalar quantities. So the C is also a scalar quantity. It does not have any direction. It's the measurement of capacity of the system. Okay. The second point regarding this is capacitance is its dimensional formula. So dimensional formula for the capacitance is m to the power minus 1, L to the power minus 2, I to the power 2, and the T to the power 4. This we get from Q and V by solving it. Okay, so this is a dimensional formula. One can memorize this formula or they can calculate this formula from the Q, which is a charge, and the value of V. Third point is regarding the unit of C. So when we define the capacitance, the unit of capacitance, which is C, either you can define the unit from here itself, it will be coulomb per volt, but this capacitance has a one specific unit as well, and that specific unit is farad. In short, we define it by F, capital F. So the unit of capacitance is farad. And this value, farad unit, basically the thing is when you calculate the unit, 1 farad is a very huge quantity. So having the capacitance 1 farad is a to have the capacitance of 1 farad will need a conductor of the size of earth, which is nearly impossible. So in normal parlance, when we calculate or when we define the capacitance, we define not in terms of F, but in terms of mu times of F, where mu is 10 to the power minus 6. Because normally when we calculate the capacitance, it comes in terms of mu. 10 to the power minus 6 factor is always there. Majority of the time that factor is there. Okay, so this farad is its specific unit, which is equivalent to coulomb per volt. And normal parlance, we define the C in terms of mu farad. The fourth point is the dependence actually. This capacitance, what it depends and what it don't depend. So this capacitance value, it depends upon the properties of the medium. It depends upon properties, and when I say property, basically I mean the density, dielectric constant, these kind of properties, like dielectric constant, these kind of properties. These depend upon properties of the medium. The capacitance depend upon the properties of the medium. It also depends upon the dimension of the conductor, which is holding the charge, or the shape of the conductor. It depends upon shape of conductor, or it can be insulator as well, but it depends upon the shape of the body which is holding that charge, which is going to hold that charge. So if the body is spherical, it will be, its capacitance will depend upon that. If the body is same body, if you make it planar, the capacitance will change. Or if you are having a spherical body, and in that spherical body, if you create a dent, there is this spherical body, and if you create a dent, by creating that dent itself, you will be changing the capacitance. So the thing is, it depends upon the shape. So the moment shape is changed, even by a fraction, the value of capacitance is going to change there. Okay. Next thing is what it don't depend. The capacitance don't depend upon the value of Q. Though in the formula you might see the C depends upon Q, but C does not depend upon Q, as well as this C, it does not depend upon V as well. So in the formula you might see that C is proportional to Q and C is inversely proportional to Q, but it's not the case. The thing is, when you calculate the value of V, it is proportional to Q, and when you take the ratio Q by V, they will cancel out. So it does not depend upon, this capacitance does not depend upon the amount of charge this conductor is holding, or it does not depend upon the potential which this charge is creating. The value of C is completely independent of that. So this C depends upon this shape and what is in the medium. Okay. So if anything you are going to change in the medium, the value of C is going to change. So in case, if this is your capacitor, and in front of the capacitor, you will bring another conductor, even if it does not have a charge. If you bring another conductor, so if another neutral, I'm making it neutral as well. So if another neutral conductor you are going to bring in nearby to this capacitor, that is going to change the C, and the value of C will be increased in that case. And why it will increase? Because see, the charge holding here, there will be some charge, and this charge will create the induction effect, and that induction effect will bring the negative charge nearby to this, and it will bring the positive charge away from it. So in terms, this will also be a conductor. So if you are going to bring any neutral conductor in the vicinity of capacitor, then in the vicinity of capacitor, due to the capacitor, the induction effect of the capacitor, that neutral conductor will become a capacitor. So it will have the more capacitance. This system will have the more capacitance. Okay, so if you are going to change the system physically, the capacitance is going to change. If you're going to change the medium, capacitance is going to change. If you're going to change the shape, capacitance is going to change. If you're bringing something in front of something nearby to the capacitor, the capacitance will going to change. It does not change if you change Q, the charge. It does not change if the potential is being changed. Okay, so these are the some important points regarding the capacitance, which one should memorize. Okay, and these properties will be using in the questions as well, so that we'll be able to understand these properties in a better manner. Okay, thank you.